So the first thing we're going to do is we're going to be talking about lab safety and some concerns that we might have if we come across some dangers or some chemicals in the lab when we do some experiments. First thing, general safety rules. Listen to or read instructions carefully before attempting to do anything. So I sometimes will just explain to you what I want you to do and how to do it. Make sure you're listening because I want it to turn out the right way, the way I want it to be done. There are some times that I will not tell you how to do it, give you instructions for you to read, and then you have to have the ending come out correctly. Now, just to give you an example of how this could go wrong, I've had experiments where I've had 3 liquids, an A liquid, a B liquid, and a C liquid. And in the experiment, in the instructions, I wrote out A liquid must be mixed with C liquid, but B liquid cannot be mixed with C liquid. And once you mix the liquids, it would change colors. So that means if you did A with C, you got a red. If you mixed B with C, you got a yellow. And if you didn't read the instructions carefully, your outcome would be different than everybody else's. So make sure you listen and read instructions carefully before attempting to do anything. There could be some safety issues with that as well. So if you don't follow something correctly, you might cause a safety issue. Something could break. It could explode. And I'm not saying explosion like a fire. I'm talking about maybe a chemical mixture that would overflow and get the floor messy, or your table messy, or your clothes messy. So you want to make sure you're listening carefully and reading instructions carefully. Wear safety goggles to protect your eyes from chemicals, heated materials, or things that might be able to shatter. For example, working with chemicals can be dangerous, but there are 2 types of chemicals. You ready for it? Good chemicals, bad chemicals. Raise your hand if you know a good chemical. Most of you have it on your table. Some hands. Yeah, what do you got? Water. Why is water a chemical? Well, obviously it's good. How many people ever heard of the chemical bond that makes up water? Yes, sir, what is it? H2O. H2O. That is 2 hydrogens and 1 oxygen. And those molecules come together, they combine, making the chemical water. Water's safe for you to drink. So we have good chemicals. So that means when I say good chemicals and bad chemicals in the elementary standards, I'm just telling you that if this chemical was to somehow get its way into your body, would it make you very sick? Would it make you die? If it won't make you very sick and won't make you die, then it's a good chemical, right? If it's a bad chemical and gets into your body somehow and it makes you very sick or makes you die, then obviously it's a bad chemical. Can anybody name a bad chemical? Yes?
Coronavirus.
I'm talking about a chemical. I'm not talking about a virus. Gasoline, that would be a bad chemical, exactly. If you drink it, you're definitely going to get sick and possibly die.
Hydrogen peroxide.
Hydrogen peroxide, exactly. Another one that I had in the other class was chlorine. And some people are like, chlorine? You mean the stuff that goes in your pool? Yes. In your pool, it's diluted, meaning there's a lot more water than there is chlorine, so it's not going to be very harmful. But straight chlorine to your skin, to your eyes, and your mouth, to your skin, it can make your skin burn. Give you definitely a rash. Gets in your eyes, it can make you go blind. Gets inside your body, it can definitely make you sick and die. So the reason why it's okay in the pool is because there's so much water compared to how much little chlorine goes into it. All right. So the reason why we talk about good chemicals and bad chemicals because we do work with some chemicals in the lab, and we need to make sure that we are protected by protecting your eyes, protecting our hands, and making sure we're safe around all that stuff. Also, we could be heating materials that could actually make something shatter. Last year, for example, when I was doing the dry ice experiment, I had a heated Pyrex measuring cup, and I poured out the liquid into the dry ice, and I needed some more liquid, so I used some cold water and put it in the hot glass. Guess what happened to that glass?
It shattered.
Shattered. It shattered. I think I did that in a 4th grade class. In my last class of the day, I was in a rush, wasn't following my safety rules, quickly put some cold water in a hot glass, and boom, it exploded everywhere. Luckily, I was at my demonstration table, and all the other tables where the students were at were not anywhere in the vicinity of the glass, of the explosion. So, next one. Notify a teacher of any spills or accidents that occur. This is a big one that I had with the younger kids. They wanted to hide the stuff, especially when we did the experiment with the water drops on a penny, and we had the cup of water in the middle of the tables, and everybody's trying to get their water. Well, in the 1st grade class, I had a group get a little messy, and nobody at the group told me any of this. They water, it was running off the table onto the floor, and I didn't know anything until I almost slipped on the floor from the water that was falling off the table. I don't know why they didn't want to tell me. Maybe they were embarrassed. Maybe they were afraid they were going to get in trouble. I don't know. Listen, I hardly ever get mad. I probably never get mad. Therefore, you don't have to worry about being in trouble. I just want to make sure everybody's safe. If something breaks, please let me know. I'm not going to be mad that something broke. I need to repair it or replace it so it can be ready for your group or the group that comes in after you, right? Or the next group I might go to. So, if anything happens, please let me know. Don't be afraid. That's the biggest thing. We don't want things to continue to happen because something's broken. I'm going to go ahead and move this all the way to this so we don't have to keep walking in front of the camera. After handling chemicals, always wash your hands with soap and water. Oh my goodness, I said this Monday in a second grade class, and we were talking about good chemicals and bad chemicals, and we were talking about the water. And so then somebody said, so if we touch water, do we have to go wash our hands? I'm like, wait a minute, we talked about good chemicals, bad chemicals. Yes, chemicals that get on your hands we have to wash. If it's a bad chemical that can either, one, irritate your eyes, and there are some good chemicals that can irritate your eyes. I have one in this container over here. The chemical, this is a good chemical by the way, it's vinegar. It gets in your eyes, it's going to burn. If you ever gotten soap in your eyes, that's what it feels like. It's just terrible. But if it gets on your skin, it's not going to do too much of a reaction. Some people do get a little bit of a rash if they get vinegar on their skin. But they make this in food, people. They have one of my favorite chips, salt and vinegar chips, right? If you've ever had a type of salad, some people order their salad with oil and vinegar. That's what they put on there. Those of you that have any ketchup, barbecue sauce, honey mustard, guess what's in it? Vinegar. So, if you use this, this would be a chemical that would irritate your eye and possibly some skin. So guess what we want to do? Wash our hands afterward using it. Especially after I'm using it. If I get on my hands and I rub my face, guess what's going to happen to my eyes? It is. You're going to burn. So, we want to wash our hands with soap and water afterwards. During lab work, here we go. During lab work, keep your hands away from your face. I just told you the reason why. And here's the one that some people don't quite understand when I say it. Tie back long hair. Why would we tie back our long hair? Yes?
Because like if you're doing something with certain chemicals, your hair could like piece of your hair could like fall off or something and then get in the chemicals.
Yeah, so if you have long hair and it falls in front of you and it gets into the chemical and then you take your hair and you pull it back, it could, get on your skin, it can get on your clothes. Those of you that whip your hair back and it splashes that chemical in somebody's eyes. Yeah, so we want to make sure we tie our long hair back. Same thing if you have long sleeves. We don't want long sleeves. We want to roll them up. So those of you that have seen me with long sleeves, they're always rolled up because I'm always doing something with some kind of chemical or flames. So we want to make sure our long hair is tied back. By the way, I forgot to tell you at the beginning of this, the reason why I'm going over these safety rules is I'm going to give you a quiz next week, the next time I'm in here. And some of you are like, wait a minute, I don't want a quiz, that's too soon. Do we need to take notes? No, you don't need to take notes. What I'm going to do is I'm going to be doing an experiment next week, and all you have to do for your quiz is tell me when to stop when I'm breaking one of these rules. I'm going to probably throw in 8 rules that I'm going to break, and you just have to tell me, raise your hand when I'm breaking a rule. And then, yeah, so it should be a fun experiment. One, it's a fun experiment. Two, it should be fun for you to try and find out what Mr. Dimery is doing wrong. I'm going to try to make sure I'm doing something wrong. I was talking about the loose sleeves. Oops, I should probably go back. Yep. Here's the other thing. Number 8 that I skipped, and I'm sorry for skipping it. Keep your work area uncluttered to take to the lab station what you only need. And the reason why is, one, if we're working with chemicals and you have something that's important, as you saw I moved the paper from up here, I didn't want it cluttered. And the reason why is because I didn't want it ruined. 2, if you have too much stuff in your area, you could spill something, knock something over, break it. And it could cause your experiment to either, one, if you're working with fire, have something catch on fire, chemicals, ruin stuff, break something, drop something on the floor, glasses break, and all that stuff. So we only want to take what's necessary to the lab with us, or to the lab table. 11, I think there's a 12, yeah. It is suggested that you wear glasses rather than contacts. Now, I only had this issue in 5th grade, that's why it's in there. When I would teach 5th grade, I had a student that went from glasses to contacts. And anytime we did a lab in 5th grade, I'd ask him, or the next day, that, hey, if you come to lab, make sure you wear your glasses that day instead of contacts. Because if you were working with chemicals and a chemical gets in your eyes, guess what's going to happen? That chemical is going to get behind the contacts and it's going to stay in the eye longer than it would if it didn't have contacts. So it's better to wear glasses for that. So I don't think I have had anyone here at Capshaw yet tell me that they wear contacts. Usually at this stage you don't really start wearing contacts anyways. Number 10, never put anything in your mouth during a lab experiment. So that means if we are doing an experiment, we shouldn't be drinking anything. We shouldn't be eating anything, especially if we've been touching chemicals, because if you touch some food and then it goes in your mouth, then that chemical's on the food and it goes in your mouth. I've seen this happen, and a lot of you are like, I would never do that. Pick up a bottle thinking it was water or thought it was their water, and they drink in the chemical that they're supposed to be using. That's why we shouldn't be having any liquids with us at the tables. If you do come to my classroom and we're in the lab, and you have, let's say, recess afterwards, then what I suggest, either one, you put your drinks on the floor or on the back counter. So, clean up your lab area at the conclusion of the laboratory period, which means, I haven't had really any problems with 3rd grade. I had a lot of 4th grade problems and a lot of 1st grade problems last year. Being that you're 4th graders now, I didn't have any problem with 2nd or 3rd. So, just make sure when you are done, you put everything back the way you found it. That way I'm ready for the next class, especially this year. My classes are back to back. They don't give me as much time as they did last year in between classes, so I'm going to need to get ready for the next grade when you guys leave. So it would help me out tremendously if we could get you to help me clean up afterwards. And check the floor. That was the other thing. I would find so many pieces of the experiment on the floor. Or my cups. Oh, remember the cup thing? So many people, I would tell, please be careful with my cups, because I think I only had like 60 of them. And I had to use them for 2 weeks, and I had to go through so many plastic cups because people were stepping on them. Not being careful around the experiment, stepping on my cups, and then I had to replace the cups because I was trying to do it by color, and then eventually it was just all colors mixed up because I was running out of cups. Never horse around or play practical jokes in the lab. That should be obvious. If you're playing around or playing practical jokes, people can get hurt, things can get broken, and that's not good. Glass safety. There's not too much that you are going to be working with some glass, but most of the time I'm going to be handing it out and checking it. However, if I miss something like chipped or cracked glass, please let me know, because if we start heating up a chipped or cracked glass, guess what's going to happen to it? It's going to shatter. Broken glass. This is very important. This is a school and safety rule here at Capshaw. Broken glassware should not be disposed of in the classroom, and you shouldn't try to pick it up. I have to get safety gloves on to pick it up. There was a point where I thought when I was at home that, oh, that's a big piece of glass. I can pick that up with my hands without getting cut. Picked it up, ended up getting cut anyways. That glass can not look sharp, but it happens, and I don't want anybody cut. Plus, we can't throw broken glass in a classroom trash can. Why? Because how many people have ever seen somebody drop something in the trash can on accident? A pencil, an eraser, who knows? I've seen people dig back in the trash can to grab their pencil out. And if there's broken glass in it, they're cutting themselves. Also, the custodians need to know that there's glass broken. That way, if it is in a bag, it's not in the trash can, because if they dump out that trash can, classroom trash can and the big trash can, and they didn't know there's glass in it, it could go outside the big trash can and onto the floor, and they would have never known, and then there's glass everywhere. And it's hard to find glass on white floor, right? So hard.
It happened in my
When pouring liquids into glassware, make sure the container you are pouring into is resting on a table at least a width apart. So if we're pouring something into a glass, we want the container about a width of your hand apart from every edge. That way, if it's on the edge and somebody's walking by, you can knock it over to the elbow. If you're pouring liquid into a glass container on the edge, how many people have ever poured something and that glass slides? You've never done that at home where you're pouring like milk into a glass?
Yeah.
And then you pour it, and the force of the milk pushes the glass and slides it. If it's close to the edge, guess what's happening to that glass? Right off the edge. Right off the edge. If a piece of glassware gets broken, do not try to clean it up by yourself. Let the teacher know. We've already said that. Do not place hot glassware in water. Rapid cooling may make it shatter. Huh. I already know that. I already know that. Don't put cold things in hot glassware.
I've done that before and it didn't turn out good. It cracked. Yep.
All right, here we go. Wear protective goggles whenever heating or pouring hazardous chemicals. We already explained that. Never mix chemicals together unless you are told to by the teacher. I will tell you when to mix and what to mix it into. Never experiment. Be like, oh, I wonder what happens if you mix this chemical with this chemical. One, you can cause it to have a reaction, explode, and not on fire, obviously, but shoot out like elephant toothpaste, if you guys know what elephant toothpaste is. Elephant toothpaste is when you mix two chemicals together and you get a chemical reaction and it gets very rapid, really quick, and it shoots up into the air. And by the way, that elephant toothpaste can get up to about 200 degrees Fahrenheit, which is very hot. So you don't want that stuff to be in your face or on your skin or in your hair. Also, you can make a chemical, you can mix two chemicals and make a poisonous gas that can make you pass out. You don't want that to happen either. And also, never taste any chemicals. You should never taste anything in the lab. Whether it's a good chemical or a bad chemical, we should not be tasting anything in the lab. And those of you that are like, but water is safe, well, I could taste water. Well, if I'm using the glass of water for the pennies, drops of water on a penny, guess how many people have touched that water? A lot. So don't eat, don't drink anything, no matter what. If there's candy in my room, used for an experiment. If we're doing some kind of fall holiday candy experiment where we're trying to find out what makes up candy, and there's candy at the table, don't be like, you know what, I'm kind of hungry, I'm going to take a little bit. And I'm going to tell you why, because people have been handling that candy all week. Fingers have been all over. People have been breathing on it. They've been hitting the floor. So guess what? Don't eat or drink anything in the lab. Just to keep you safe. Don't want to get sick. Smelling. Whoa. Thank goodness I have my vinegar with me. Any chemical, whether it's vinegar or good or bad chemical, there's a safe way to smell chemicals, right? The best way to smell a chemical is not by sticking it under your nose. That's not what you do. You take the chemical, hold it away from your body, and take your hand and waft the smell to your nose like this. That way you don't get the full smell of the chemical. Because some chemicals, just smelling them, could make you pass out.
Or kill your brain.
It could. And some people have gotten a poisonous gas and probably could possibly die from it as well.
It happens.
So waft the smell. I'm not concerned about you doing any smelling in my classroom because I'm the one handling the chemicals, but this is just a general safety rule, especially at home. If there's any chemicals in your house, don't just go around smelling them. And if you're not sure what it is, it should always be labeled. In my classroom, all chemicals are labeled, and there's also safety labels on it. If you see a skull and crossbones, are you going to take it and smell it and drink it? No. If it has a circle on it with that line through it, where it says it has eyes on it with a line through it, it means it's not safe for your eyes. If it has a nose on it, line through it, it tells you not to smell it, right? If it has a skin or a hand on it, it has a line through it. Guess what? You can't touch it with your skin. There's a chemical in my room that has all that stuff on it. You can't even smell it without a mask on. And I'm not talking about this mask. I'm talking about one of those charcoal breathing masks. Or that's if you're in a room. If you do open it without a mask, you have to be outside in a well-ventilated area. And there's some other ones that have circles with flames on it, right? Which means don't put it next to any fire because it could catch on fire. So there's the smelling rule and all the other ones about labeling. Chemical safety, I kind of went over it. We don't want to dispose of any chemicals down in the sink unless I tell you to. One of the biggest ones that children like to pour down the sink is that polymer, the instant snow polymer. It's a powder you pour water on and it expands into big giant snow. Or it looks like snow. A lot of people just, when they were done using it, they put it down the sink and it still expands and then it gets inside the pipes and it can cause a clog, break the pipes and all that stuff. Slime's another one. Slime is not good for the pipes. Don't put that down the sink. Slime, don't put it down the sink. It'll ruin the pipes. Wash your hands after handling hazardous chemicals. I know you've heard that so many times, but I keep putting it in there so it reminds you. Anytime you touch a hazardous chemical, wash your hands. Heating safety. We're not going to really talk too much about heating safety. If there's any heating that's going to be happening, I'm going to be the one doing it. So we're going to go ahead and skip through some of this. Number 3 is kind of a funny one because there's a story about it. Always point the tops of test tubes that are being heated away from people. It kind of goes back to that Mentos Diet Coke that you've probably seen on YouTube. I've seen videos on YouTube where they're putting the Mentos in the Diet Coke, you know, it makes that chemical reaction where the soda comes out. They put like 1 in and they're like, nothing's happening. They put 2 or 3 more in and they're looking over and the next thing you know, right in their face. Same thing happens to test tubes. You're heating up a chemical, you're mixing some chemicals in a test tube, and you're heating it. It might take a while for it to make that chemical reaction happen. And if you're looking over it, guess what? Right in your face. Don't want that to happen. Test tubes. You don't have to worry about heating test tubes in this in 4th grade. If there's any heating of test tubes, I'll do it. But you usually put them at an angle. That way, you have to rotate it back and forth. That way, the heat doesn't stay in one spot. And those of you that don't know what a test tube looks like, I have one that's very similar to a test tube. This is called a baby soda bottle. And it's actually made by the Pepsi company. This is what the 2-liter bottle looks like before they put air into it to make it bigger. So this is if you didn't know that, this is what they look like. Soda bottle.
Wow.
This is a 2-liter soda bottle.
No, it's not.
And it is. So if you look online, you'll see that they'll stick it on a machine in a mold, and they'll put air into it and they'll put the air into it, and when it inflates like a balloon into the shape of a soda bottle. So this is a baby soda bottle. This is how they get so many soda bottles into a small area without, you know how big soda bottles are.
Yeah.
Wouldn't you store these a lot easier than bigger ones that are already expanded? So they'll store these, and when they need a soda bottle, they'll grab this, put it in the machine, blow it up like a balloon, and then stick it in the machine to put soda in. And it comes with the Pepsi cap too. I don't know if I have it in here. I might have left it in the room. Oh no, here it is. There's the Pepsi cap. And it has that little plastic piece on it too. So it's pretty cool. I got that from a friend that used to work at Pepsi, and I asked in Florida. I asked somebody here that works for Coca-Cola, and they're like, we don't carry those. You'd have to go to Atlanta to get them. So I asked somebody here that worked at Coke to see if they could get me some of them. And they said they have them in Atlanta. So since that person doesn't work in Atlanta, they couldn't get me any. We're almost to the end here. Heating safety, we don't have to worry about that because I'll be doing it. First aid, this is very important. Burns, whether it's a chemical burn or if you're on the playground, on the monkey bars, and you get a burn, here's the first thing you need to do for first aid. Immediately flush cold water on it. Why? Because what it's going to do is it's going to take that burning sensation and it's going to lessen it. It's not going to take it completely away. It's just not going to make it burn as bad, right? It's not going to have that sensation as bad as it was. So put water on it, cold water on it, as soon as you can. The next one, cuts and bruises. I've seen this in kindergarten, years, where a kid cuts himself on the arm in the playground. You know, you're going down something, you're running, and you get cuts, and their best friend comes up to the teacher, and their best friend's holding their cut. First of all, rule number 1: don't touch anybody else's blood. All right. If you are bleeding to the point where it's dripping and stuff, you hold your cut with pressure to stop the bleeding. Go to a teacher, let the teacher evaluate to determine what the next step is, whether you just get a Band-Aid or you need to go to the nurse. But don't let anybody else touch your blood. Another one I see a lot of here in Capshaw, nosebleeds. All right, nosebleeds. The biggest thing is I see a lot of people cupping their hand trying to catch the blood and their head's over their hand. And they're like, my nose is bleeding. Well, the first thing you should be doing to stop that bleeding, don't tilt your head back, don't tilt your head down. Take your pinching fingers and pinch the bridge of your nose, not down at the bottom. Pinch the bridge of your nose here and keep your head level. If you tilt it back, all the blood's going to go down your throat. You put your head down, you can possibly pass out. So just pinch here to stop the bleeding. And if you need to catch any blood, you can put your hand there. But if you try to open any doors, let somebody else open the door for you.
So like this?
I've seen people with blood on their hands try to open up the door. And I say, no, don't touch the door. Or try to turn on the faucet, right, to wash your hands. Let somebody else turn on the faucet for you. Because then you're touching the faucet with all your blood, touching the door handle with all your blood, and then we have a problem. And we have to get some special chemicals to get all that cleaned up. So, follow safety rules with that. Bruises. if you feel like you hit something hard enough that you're going to get a bruise, instead of getting that big giant mountain of a bump and you just want a little hill, put some cold ice packs on it or something to stop the swelling, all right? Because the longer it takes to get ice on it, the bigger the swelling will be. So we want to get ice on it as soon as we can to slow down that swelling. I'm not going to say it's not going to swell, it's just not going to swell as big. And the last one, the eyes. If you get a chemical in your eye, or if you get a foreign object, and when I say a foreign object, something that doesn't belong in your eye, gets in your eye, the first thing you should do is try to rinse it out with water. Now, you have a natural reaction to close your eyes when water comes in front of you, right? So you might need to do one eye at a time, hold your eyelid open, and splash water in to get whatever's in it out. The biggest thing to do is not to rub your eye. If you get something in your eye and you start rubbing it, what you're doing is you're taking that particle, whether it's sand or something else that's in there, and you're rubbing it and scratching the inside of your eyelid, scratching your eyeball, and you're just making it worse. So try not to scratch your eye. Best thing to do is to flush it out. Somebody told me that they do the drops in their eyes to try and get it flushed out, and I said that's fine too. So I think that's about it. It is. So the next thing we're going to do, a little demonstration that you can do at home. So I'm going to get my light person to get the lights for me. And if you can just do one light would be perfect. If one, oh, perfect, there we go. All right, let me see if I can get this to turn to a different screen here. Go to a different screen. There we go. All right, so the experiment I'm going to do, yes sir, you got a question? Yeah, go ahead. The experiment I'm going to do is going to do with two chemicals, two good chemicals. Hopefully, Ms. Bowles doesn't care that I'm moving this. I think what she has though is the wheels are locked.
Yeah, they are.
So I'm just gonna slide it.
So, Mr. Newman,
Yes.
you saying that two good chemicals could make one bad chemical?
No, it's not like math, where two negatives make a positive. There we go. All right, so nobody is in view except for me. All right, so I have vinegar and I have baking soda. So the baking soda is obviously okay as long as it's used for baking. You shouldn't be putting it in your eyes, obviously, it's not for that. Don't eat it by itself because actually baking soda is a sodium bicarbonate and the sodium is salt, so it's really salty tasting. And the bicarbonate is actually a mixture of other things that are trapping a gas that you guys are known to called carbon dioxide. Does anybody know what else has carbon dioxide? Yes, sir?
Carbonated drinks.
Carbonated drinks, exactly. That's what makes the little bubbles, exactly. And you know there's a gas in your carbonated drink because of those bubbles. Another one that is very important that you need to know is that we breathe in oxygen, but we also breathe out carbon dioxide, which is the same stuff that's trapped in the baking soda. Now, to get that carbon dioxide out, we need an acid. So the acid today is going to be a vinegar. And that vinegar is going to break that chemical bond up. It's going to leave the sodium and separate the bicarbonate into carbon dioxide. And we can see that once we pour it into a cup. I'm going to get rid of this water in here real quick, because water really doesn't help the experiment. And just to give you an idea of what it looks like, I'm going to pour just a little bit in here. And Miss Bowles should be all right if I mess up her table, right?
Yeah.
Yeah, I'm sure. And when I say mess up her table, I mean put a little baking soda on it. Yeah, by the way, baking soda and vinegar is a very good cleaning product. This is a natural cleaner, by the way. And so if anything, I'm cleaning her table. So the reaction we're going to get is what?
Explosion.
We're going to get an explosion? I don't know about that. What are we going to get? What are we going to see when I take this acid and this base and we mix it together? We're going to get a solid, liquid, and a gas. And we're going to know it's a gas because of what again?
Carbon dioxide.
Carbon dioxide. But you said what are we going to see though? You said it.
Bubbles.
Bubbles, yes. Now, you know you breathe out gas if you put your head underwater and you breathe out, right? You make bubbles. We know gas is happening because it's going to make bubbles. So let's go ahead and make some bubbles here. let's go a little bit further and see if we can get it to overflow.
Yeah.
I'm joking. All right, don't go any higher. Slow down. Stop. Stop. All right. As you can see, we can see the bubbles, and it is making carbon dioxide. Here's my question to you. Since carbon dioxide is what we breathe out, if I was to get a balloon here, and I show you the gas, because right now, the only gas you see is the bubbles making, right? Do you see the gas anywhere else?
No.
Gases are hard to see. So we went from a solid, we added a liquid, we turned it into a gas called carbon dioxide, which gases are hard to find or see in the air. So if I was to blow this balloon up, we could see the gas. It's going to take the shape of the balloon, right? But we can't actually see it.
Yeah. Whoa.
Never seen a balloon blown up before? Listen, I'm not a clown or anything. I promise.
You
All right,
are because you
so now that we have the balloon tied, here's the question I have for you. This is a little thinking one. I don't want anybody just to shout out an answer. I asked this question in 3rd grade the other day, and half the class, they were divided. Half class said one thing, the other half of the class said another. And I've been asking this question ever since Tuesday. I didn't ask it on Monday. So here's my thing. My question is, whoa, slow down, balloon. If I was to let go of this balloon, what's going to happen to it? Is it going to go up, or is it going to go down? And I said don't call out the answers. We need some think time here. Some think time. Is the balloon going to go up, or is it going to go down? Instead of just calling on one person's opinion, I want everybody's opinion. I want you to raise your hand if you say the balloon's going to go up. You can be by yourself. It's not bad. Raise your hand if you think the balloon's going to go down. Okay, so you don't know. It's okay not to know. And that's what science is all about, because guess what? We do the scientific procedure. I've asked the question, now we need to test it, right? We had a hypothesis of some of you saying it's going to go up, some of you say it's going to go down. So now the next thing to do is just test it and see what the results are. And so when I let go of it, it goes to the ground. And here's why. You ready? Carbon dioxide is a very dense gas. And because us being on Earth and we have gravity, that density translates to being heavy. Got it? So this gas is heavier than most gases. What gas could I put in the balloon that is not very dense, which would float in the air and go up, which is lighter than the air that's in this room? What's that gas called? Yes, sir.
Helium.
It is helium. You could have also said hydrogen. You could have also said hydrogen as well. Hydrogen and helium they're not as dense as carbon dioxide, which is going to allow the balloon to sink to the floor. They're going to float. So that brings me back to this cup that we've made with bubbles. So if I add a little more vinegar to this, or a little more baking soda, we would get the same reaction. Now, those bubbles and that hissing sound that you hear, we know it's making carbon dioxide. My question is, where is the carbon dioxide? The carbon dioxide I'm making, where is it right now? Where's the carbon dioxide that's just happening? It's still making, I can pop some of the bubbles and still make the carbon dioxide. Where's all that carbon dioxide going? Yes, sir? It's in the bubbles, but the bubbles are popping, so where's that gas being released going to? Going to the air. Where do you say it's going? But I just showed you carbon dioxide doesn't go up. See that?
It's going down.
So where's the carbon dioxide at?
It's going back down.
Going back down. So where is the carbon dioxide?
It's going back down.
It's in the cup. You guys want to see me pour it out?
Yeah.
All right, so I'm going to pour out the carbon dioxide.
On the tail.
See, you're confused. I just poured the carbon dioxide. This stuff in here is sodium and vinegar.
Carbon dioxide is gas.
Carbon dioxide is a gas, so I just poured out the gas. Now, what I'm going to do, though, and the reason why I'm telling you this, is because I'm going to make a fire extinguisher. Now, there are 3 types of fire extinguishers. They can be debated. There's different chemicals that make them, but the 3 main ones, there's a foaming one, there's a water one, and then there's a powdered one. Now, that powdered one is pretty much baking soda, and it's mixed with another chemical that will break that baking soda into carbon dioxide and then shoot out the nozzle. So that's why you see like a white powder when you see that fire extinguisher released. And the reason why those foams and water and the baking soda fire extinguisher or the powdered fire extinguisher work, because fires need two things. They need something to burn, like paper, carpet, anything that's flammable, and they need oxygen. Oxygen, if you ask any firefighter, is the worst enemy for them. And the reason why is because more oxygen makes that flame go bigger. If the firefighter can get rid of the oxygen, guess what happens to that flame? It goes out. The fire goes out if you don't give it any oxygen. So guess what? I'm going to show you an experiment you can do at home using baking soda and vinegar to put out a flame. And obviously it's not going to be a big one. That's why I'm going to use a candle. I know. Hold on. All right. So, yeah, the little tea light candles. Yes, exactly. So here's the thing I want you guys to know. Listening. When you do this at home, you need adult supervision because you're working with fire. And the second thing is you might need a little practice because there's you have to put just enough vinegar in so you don't cause it to overflow. Because guess what you want to keep in the cup? The carbon dioxide, because that's the only thing you want to pour out. So I'm going to put a little baking soda in here. And it's really not the baking soda of how much. You just want a nice general amount of baking soda in the cup. You don't need a whole bunch of it. The mixing part of the vinegar is going to determine how high it gets. So if you put a little vinegar in it, it's going to go up a little bit. You want to get the vinegar about halfway up, or the bubbles halfway up the cup, because you want the top of the cup to be trapping the carbon dioxide. That way when it's time, you just pour out the gas onto the flame and it should put out the flame. Got it? Once again, adult supervision, and this is not a real fire extinguisher. It just pretty much tells you how a fire extinguisher works. Just takes away the oxygen. So those of you that can't see the flame in a minute, don't worry. I'm going to hold it up again in a second. So I'm going to put that down so I can mix the chemicals. Don't worry. I said if you can't see the flame, you're not going to have to worry about it because I'm going to pick it back up and hold it here. So if you can see my hand here, you're going to see the experiment, all right? So now here's the tricky part that you're going to have to practice. By the way, when you do this, you could probably put out the flame 2 or 3 times with one mixture, all right? It just gets harder every time. The first one is the fastest. The second one, not so bad. The third one, you kind of have to work at it to get the flame out. So we'll try it. The first time it's going to happen real quick. Pour just a little bit in to get it halfway up. Oh, slow down. All right, here we go. Carbon dioxide is where? In the cup, because it's a very dense gas. And we're going to go ahead and just pour out the carbon dioxide. Here we go. 3, 2, 1. I told you what was going to happen. Now, before I lose all the carbon dioxide, hopefully I didn't pour it all out, I'm going to swirl it around to try and get some more carbon dioxide to release, and we'll see if we can get it to go out a second time. Ooh, told you it gets harder and harder every time. Oh, it danced a little bit. I told you it gets a little harder, and I let it sit for a while. So what we can do is add a little more. Add a little more baking soda. A little more vinegar. Oh, whoa. Slow down. Don't come out. Slow down. All right, here we go. 3. Those of you that had a hard time over there, stand. 2, 1. Pretty quick, huh? All right.